Now we turn our attention to continuous random variables. We will begin with the important concepts which apply to all continuous random variables in general, and then we will learn to work with the special case of normally distributed random variables. We already stated that continuous random variables can take on any value in an interval. The interval can, at least theoretically, range from negative infinity to positive infinity. Because we cannot list each value, the probability function, probability that x equals x, used for discrete distributions, cannot be used. Here we illustrate what happens when our intervals become increasingly small. The area of each rectangle will also become increasingly small. For a continuous random variable, we can no longer add rectangles, but must find the area under the curve. This curve is called the probability density function. The underlying mathematics requires calculus, and so we will rely on tables or online calculators to do the required calculations. For continuous random variables, the probability that x equals a number x is equal to 0. However, the probability that x is between a and b makes sense and will be found as the area under the probability density curve for that random variable. Let's think a little about this. If I tell you a person's height is 62 inches, what does that really mean? For measured variables, such as this in research, it will mean that the person's height rounds to 62 inches, which will mean that the person's height is greater than or equal to 61.5 inches, but less than 62.5 inches. So we could find the probability that 61.5 is less than or equal to the height is less than 62.5. The area between A and B under the PDF is equal to the probability that x is between A and B. For continuous random variables, it doesn't matter whether we include the equals in our probabilities, since the probability that x equals x is 0. Be careful, as this distinction remains important for discrete random variables, which you may see again. Finally, it's important to note that the total area under the probability density function is equal to 1. Any shape is possible in order to model all types of real-world situations. The probability density function has large values in areas of high probability and small values in regions of low probability. However, the value of the probability density function, the height, is not the probability that x is equal to x. Here are a few examples like those we will be working soon. We will learn to calculate probabilities and work backwards from probabilities to find scores. In these problems, it's good to sketch the situation and the area of interest. Notice again on the lower right that to find the probability that x is less than 9 is the same as finding the probability that x is less than or equal to 9, since the probability that x equals 9 is 0. Similar to discrete random variables, there are equations for the mean, variance, and standard deviation. However, these equations require calculus, and we will not be working with them in this course. Continuous random variables require a different approach than discrete random variables. We must find the area under the curve in order to calculate probabilities. Now we will focus on the normal distribution.